All right. So page 19 and 20 both go together here. See if I can. Probably need at least one light on there. All right. So unfortunately, I can't like zoom in very much here in making some of this these, you know, the font any. Or maybe I can't. No. Yeah, even farther away. Make them any bigger there. So I'll kind of point things out though here. So oceanic crust is always going to be labeled or color blue there. Continental crust is always going to be kind of this gray, greenish color here. And so this is a simulation where there's things that you can control and you can alter. So if you look up here, there's temperature. So I can make the temperature cooler or warmer in the crust. The composition, if you did begin your reading yesterday with the mantle plumes that you're supposed to kind of do on your own there, you may have recognized, maybe some of those like difference between iron and silicone or silica is listed on here. And then thickness, thin or thick, as far as that goes. So that's the my crust is this one here in the middle. So if I make it thinner, it's like that. Thicker, it's like that. So when I adjust the thickness, you notice what happens? Yeah, it changes from oceanic to continental. So at some point, it becomes too thick to be oceanic anymore. It must be labeled as continental. It'll rise up above the water. As far as the composition goes, again, you can kind of see if I adjust the composition and make it more silica, what does that do? Yeah, and it makes it more continental. If I put more iron, it makes it denser in zinc because iron is a more dense metal. If you guys look on our periodic table, where's iron? It's 26. So it's the letters Fe, right? So iron's has a mass there of 26, or an atomic number of 26. The mass is a little bit higher, that number below there, but that's not something we'll learn later. But silicone or silica, it's the same idea there, is 14. So it's almost twice as heavy. So when you have more iron in your crust, it's likely going to be oceanic crust and be very dense. Okay. So that's why when we change it to more iron, it becomes more oceanic. When we change it to more silica, it becomes more continental. And then temperature, all right. Doesn't look like temperature necessarily affects the crust, making it whether doesn't necessarily make it completely one way or the other. It does, kind of lighten it a little bit, but not as much as the other ones do. All right. Let's see here. So according to the legend down here, if you see anything again that's lighter in color, it's less dense, and darker in color, it's more dense. I can also turn on the density meter there so we can see that way. Here's my temperature will go up so I can kind of look at it that way. And that's like the thickness and how deep it goes. So we can put like show labels here. So now the crust is labeled. So the crust is always this lighter portion there. The mantle is always this gray kind of darker portion down here. And the mantle obviously would be more dense. All right, so let's kind of run through the steps here. Okay, so part 1, it says select the plate motion tab at the top. So that's this one right there. Okay, drag and drop a continental crust on the left side of the simulation. All right, so continental crust. Put that over here. And then drop a young oceanic crust on the right side of the simulation. So we have young oceanic crust and old oceanic crust. Can you guys tell the difference between them? Old looks darker, and according to our legend, darker means it's denser, right? So I'm going to take the young oceanic crust and put that here. Your simulation should now look like that picture there. It says pull the lever and answer the following questions. So here's our questions. What type of boundary will be created, divergent, convergent, or transform? What begins to happen under the continental crust after 12 million years? The years will come up. Where is it? Oh, up here. So time elapsed. All right. So look for, once you hit that 12 million year mark, you should start to see something happen under the continental crust. What type of landforms are created by this boundary? And then where would you find a real world example of this simulation? So you might have to page back in your notes for a sec there. Okay, so I just stopped it here at 13 million years. Okay, so you saw that the crust just kind of kept coming, comes into the continental crust, starts to sink. So go ahead and answer questions 1 through 4. I'm going to kind of keep this going here. So this is what's beginning to happen after that 12 million year mark. This white stuff that you're kind of seeing almost like bubbles, that is magma starting to form here. And it rises up to the top. Start to see some different things coming up on there. So what is being created up there or on the continental crust? What are these little things here? They're not trees. They're volcanoes, right? So what do I call a chain of volcanoes on a continent? Volcanic mountains or volcanic arc. Okay. So I'm going to reset this so you can kind of watch it a little bit too from the beginning. Oh, I didn't mean to reset it completely, but it's fine. We can do that. So you can see as the plate is subducting, it once it reaches a certain level in the mantle, that's when it starts to. I wish it was like red. Just makes more sense for magma to be red or orange instead of white, but so I'm gonna show this shows okay. I'm gonna set that again. So now I have some colors on here. The sort of shading, whether it's light or dark, is density, and the temperature is this red. So where you see the red there, that's where we get the magma. Maybe that's why I had to have that there. So let's see what label shows seawater. Yeah, we can have all that. Let me take off density. Just show temperature. So now I'm just showing temperature so you can maybe see that magma start to form under the crust a little bit more. All right. So I would say for number 3, landforms that are created by this type of boundary, at least 2. There's another one that I might label, but it's not a landform. It's like inside the crust. That'd be like the subduction zone. So what do you think I want you to label on this one? The trench in the volcanic arc or the volcanic mountains. Okay, go ahead and look back in your notes for this specific type of boundary. Now, you should have probably answered that this is a convergent boundary, right? But this is a very specific convergent boundary. This is not just, we have 3 types of convergent boundaries. So make sure that you pick the correct real world example of where you would find something like this. So is this an OO boundary, OC boundary, CC boundary? Take a look for that in your notes. All right. Anybody need more time? Okay. All right. We're going to move on to part 2. There's 6 parts here. So now we're going to click new crust. Let's see. Okay, now it wants me to put a continental crust on the left and a continental crust on the right. And run the simulation. Pull, it says one of the green levers. All right, so if you guys want to start taking a look up here. Okay. So this is continental crust, and I'm pulling the lever towards the green, which means they're coming together here. So you can start to see some, what ends up happening when you get 2 continental crusts that come together. They really buckle. They fold. Those are those folded mountains that we were kind of talking about. It only goes this far here. So, and look how much the crust and the lithosphere got thicker in this section, because these 2 massive pieces are coming and being forced together, and they have to go up, but they also kind of go down into the crust and the mantle too. So I'll rewind that and we can watch that again. So you can see the lithosphere and the continental crust both thickening, right, over that time period. So again, what type of boundary? Number 5, one of those 3. What type of landform? I would say there's probably just really one that you need to worry about here. And then you can go ahead and this is a CC boundary, right? So go ahead and look back in your notes. What was the one example we talked about with the CC boundary? So I have the temperature marked here, but notice that there is no real increase in temperature that occurs. There is no magma that occurs. Let's see if if the density changes. I don't know that I don't think it's really changing. Maybe a little bit, but I've gotten a little bit less dense, but I can't really tell. So 3 questions for 19. Memphis, you ready? Okay. All right. Go ahead and turn the page to page 20 if you haven't already. Okay, so on this one, crust here, I'm going to grab a continental crust and a continental crust. Now this time it wants me to pull the red lever, pull it towards the red side here, and see what happens with that. Yeah, that's all I need to do. Woo, that goes fast. Okay. So I'll reset that here. All right, so we start off with 2 continental crusts that are meeting here in the middle, and I'm pulling both of them to either side. All right, so as I start to do that kind of slowly here, this starts to separate. Now, it does kind of fill in with ocean water right away, but if this was somewhat higher of an elevation, it may not fill in right away. I mean, it's got to be close to sea level if it's going to fill in with ocean water right away. But a lot of them start off as what we call those rift valleys, right? Where it's still land, but it's just land that has dropped down considerably. And eventually it will fill in with ocean water as it makes its way, towards the ocean. But so it might not fill in with ocean water quite so quickly, but you get the kind of the same idea here. So as these crusts and pieces are separating, you see that magma there. I'm going to put my temperature on. Oops, temperature. Kind of hard to see that magma there. Why would they not make it like a different color? I'll keep it on this one. It's easier to see the magma coming up. All right. So again, it might start off as like sort of just a small kind of slip between two pieces of crust, and then eventually widens to become more of an ocean type of structure. So this is very similar to what would have happened to South Africa and Africa. So if I reset this one more time, let's say this one here on the left, that would have been South America. And this one here on the right would have been Africa. As I separated them, all right, or as they separated, then this is a baby Atlantic Ocean right here. Okay. So baby Atlantic Ocean that's forming there. And it just continues to widen and widen over millions of years. More crust being formed there at the center. So you should be able to list down at least a few different types of boundaries, or not, it's not boundaries, landforms. One for sure. Did anybody have another one besides the mid-ocean ridge? Oh, Rift Valley. Yeah, Rift Valley maybe at the very beginning. Yep. And then there are quite a few places, examples that we talked about for number 10. So and your example could be either a one that's associated with the Rift Valley, or it could be one that's associated with the mid-ocean ridge. Anybody need me to play that again? Okay. Alrighty. I'm gonna move on to part 4. Part 4 wants me to grab 2 continental crusts. And this time I am going to be pulling towards the blue arrow, which is more so horizontal, from each other here. So go ahead and kind of watch and see what happens here. So I have 2 pieces of continental crust. The blue arrow is going to show them start moving this way. So that left piece is coming toward us, right? And that right piece is moving away from us. So again, what type of boundary would that be? Mm-hmm. Now landforms. Are there any major landforms that are created here? I would maybe like the crack itself. I would probably list down. It's called a fault. You can maybe list that down for the types of landforms, number 12 that are created. Otherwise, not a whole lot, because no magma, so no volcanoes, no trenches, no mountains of any kind. really just this fault line here, or basically that's just where they're separating. They do have a lot of earthquakes, but all the boundaries really experience earthquakes. But earthquakes isn't a landform anyways, so yeah, I would say just maybe fault line or fault is good for that. Okay, make sure you do 13. Where would you find a real world example of that? Again, we talked about one in your notes. Okay, part 5 says young oceanic crust, and then drag and drop an old oceanic crust. All right. Let's see. Try this one first. And we're pulling the green arrow. All right, so we have young oceanic crust on the left, old oceanic crust on the right. Old oceanic crust, the reason that that one starts to sink is because it is denser. I was going to say, I'm not sure. I can't see a huge difference, I guess, between these, but we did kind of, we talked about it as we pulled it up, but now it doesn't really, let me rewind it. I don't really see a huge difference in color, but there should be. There should be at least a small difference there between densities of these here. But we understand that. So old oceanic crust starts to sink down. So that's, again, what type of boundary? Main type of boundary. And then we start to see this process happening again where magma starts to bubble up through the rocks, and we'll see what gets created there. It takes a little while to get these because they have to travel all the way through the ocean water as well. Okay, so then we get a chain of islands here, and you can kind of see how that crust in that lithosphere there sort of starts to, it gets thicker in those island spots as well, and thinner on the sides too. But all that's coming from, magma subducting on being created by a subducting crust, old oceanic crust. All right, so I can think of at least 2 landforms that you should have listed here. Trench, yeah. Island art, good. All right. So for part 6 here, the only other thing we really haven't used here is this toolbox. They have this ruler, which if I put it up here, can kind of measure like thickness or whatever. I don't know necessarily with that one. Would be useful here. Let's see. Okay. So take a look up here. We're going to, we're just going to stick, it says to choose one of the 5 simulations that we ran. I'm just going to use this one because I'm already on it. And what we want to do is we want to watch how the temperature changes. So I grab the thermometer here. So I'm going to get the simulation kind of going a little bit here. Actually, let me get it going quite a bit. So you'll notice that the temperature as the thermometer stays here, it hasn't moved at all. When I bring it up to the lithosphere, did it go up or down? It went down a little bit. And that makes sense because it's warmer inside the Earth. all right, and it's cooler towards the surface, all right. So when I go, look what happens when I click on into that old oceanic crust. Now your temperature is very low, okay. But if I click on this oceanic crust, the temperature is not quite as low. So usually, the older oceanic crust is a little bit cooler, okay. So towards it, you can just put something down there, like towards the crust, it's cooler and it gets warmer as you go to the middle. So you should be writing this down for part 6. How does the temperature change in different parts here? It's cooler in the crust and gets warmer in the lithosphere and even warmer in the mantle. So again, cooler in the crust and gets warmer in the lithosphere and even warmer in the mantle. But now let's take a look at this, this zone here where I have where I have this magma starting to form here. So if you look right here, I have the crust here, this more part of the mantle, I guess I would say. This is still pretty warm. This is this is cooler because this was crust that was up here at one point, right? So this line right here of oceanic crust stays pretty cool as it makes its way down here, and then this is where it starts to get hot again. So the magma is hot. All right. Compared to some of the that oceanic crust, and it gets hot as you get up towards here too. Okay. So it's hotter near the magma if you wanted to add that. Let's try density and let's see how density changes. So this is more like a speedometer type of scale. So if it's towards all the way here, like I am in the mantle, you can see that it's very dense. Okay. So pretty much everywhere in the mantle is dense. Not too much difference between density in the mantle and lithosphere. The oceanic crust is a little bit denser there. It should be. I don't know if there's a noticeable difference between. So there is a slight difference. It's barely noticeable. But the young oceanic crust is not quite as dense as the old. You can see the young one goes to about that like 4th line from the last. If I go over here, it's almost to that 3rd line from the last. So just a very slight difference. So generally, density increases as you go deeper into the earth. I would say that's pretty good. All right. So that's all I have for that for today. And then you just need to continue working on pages 23 through 26. That is, again, that mantle plume reading along with your doodles or drawings. That is done on your own time here. You have work time to do it, but it's not something that we do together or anything like that. You need to be reading through them and answering those questions there. So work on that, finishing that up.